first class for the Linux training. So the agenda that I have is to give a little bit of detail about the training, how I have planned this, and what are the topics that I'm going to cover. I'll talk about that for 5 minutes or so. If you have any doubts, if you have any clarification, we can ask. You can ask that. After that, we'll move on to introduction to Linux and some more basic things on the Linux, and we'll close for today's class. So this is the agenda that I have for today. We'll move on to the details about this training. I have segregated into 3 parts, part 1, part 2, and part 3. Part 1 would actually list down the topics that I listed down here: introduction to Linux, commands in the bash commands, basic bash commands that I'll be talking about, backup and restore, file systems, user management, and package management. So these are the topics that I'm planning to cover in the part 1. Part 2, pretty much all of these networking stuff, including DHCP, network file system, Samba, NIS, web server, Apache, DNS, FTP, mail server, and proxy. And part 3, I'm planning to cover RAID, graphical environment, genome, KDE, and server security, which includes firewall, IP tables, then web admin, troubleshooting, cluster management, and migration OS. So this is how I planned this training to be, and I planned this for about 5 to 6 weeks, pretty much like 1 to 1.5 weeks for each and every part. So this is what I'm looking at. So if there is any differences in your understanding, please let me know. So because that would be good as we move along.
Okay, so this one in the last session, that's what we discussed about the different types of nodes and the migration of OS.
It is there in last two.
And cluster management is related to this one. Okay, troubleshooting.
Yeah, cluster management, the tools that you talked about, the synchronization tools, right?
Yeah, so these tools are part of the cluster management.
Correct. Yes, that's correct.
And the repo buildup, repository, and so on is also included there.
The package management is there.
Yeah, package management in the part
Okay,
1.
so what is first in the beginning? Okay.
Is there any chance like to move this cluster and cluster management into somewhere? Like, is it how the flow will work? Only then we will understand if we do it at the end.
Yeah, I thought I'll start from the step by step. So because cluster management would need requirement of networking and things like that. So I just taken it after networking. So maybe if you want to include cluster management in part 2, then probably I can have it. Is that okay? If you want me to start with the cluster management as part 2, starting of part 2.
Oh, okay, in that way. But how about this backup and restore, package manager, and this cluster management? If you can make a bundle kind of thing, all together. Looks like this is related to each other, right? So I don't know what you mean by backup and restore. Is the backup and restore of the whole backend files, or just the folders, directories?
Yeah, so the backup and restore is an item that I have given it here just to, in case. So one more thing is, in case if you find any of these topics is not very relevant, so probably we can remove that and we can add in some other topics in case if you feel so. The backup and restore as such basically would involve something like taking backups, writing cron jobs, and taking dumps and restoring the files in case of something going bad and things like that. So if you feel that's not very relevant, so probably we can take it out and then we can put cluster management instead there.
In fact, it is relevant, but we were just trying to align this along with the cluster management. I mean, at this stage, we are fully aware of the server and the different nodes. So this time, this point of time, we can run through the full backup of the server or a backup of the specific files and their restores. Is what
Yeah,
we
so
were discussing.
so the backup of the specific files, automatic backup. So that's also part of that. So cron, there's a cron job kind of thing which we can
Okay.
write, which will automatically take the backup from different servers and put it in a different
And,
backup
okay,
server
clear.
and things. Yeah.
Okay, so
So
that will be part of the cluster management.
that's part of the backup and restore. Okay,
Oh,
fine.
okay.
So, Shafi, so what I will do is, what I understand from you is cluster management, you want it in the part one. So I'll try to put it in the part one. I'll start like this cluster. So do you want I mean, even the network management, the whole of these things inside a cluster, or you want to have it as a base thing for all of your training? So is that what you mean? So I need to clearly understand that. So for example, what I mean here is, do you want to have the DHCP demonstrated on a cluster? Uh, so something like that. Is that what you are looking for?
I mean, yes, I mean, node-wise, let's for sure. For example, I think our understanding is we will take a single node and try to go through this basic commands and basic understanding of the file system and so on.
Yeah,
But
so that's
things,
what I have planned. So that's what I have planned. So I
okay,
have planned for the part one, I'll go with one node or one virtual machine.
Yes, yes, sir.
I'll go with part one, and then part two, I will have to have at least two nodes,
Yes,
have the DHCP, NFS, and all of these things would work. And when we go to part three, we will have to have multiple systems, at least you said like three systems, put them in a cluster, and then we'll try to see. But again, firewall security are all individual node based. But in part three, I thought like, so cluster management, I'll plan to move it to part one, end of part
no,
one.
I
Is
think,
that okay?
no, it will be okay in part three, but I was just thinking the other way around. The backup and restore will be clubbed with cluster management in part three. This is what I
Oh, okay,
was.
okay, okay. Yeah, yeah, okay. So that, yeah, that way, I mean, it's all, I mean, we can't very much,
we will be taking
it's
Ansible.
all interlinked and or overlapped stuff, because when we learn, we need to learn step by step. So that's how I arrange it like this.
Okay.
Yeah, so I will try to bring in cluster management whenever, I'll try to bring in some demo based on a cluster when, as and when it requests. So I hope that should be okay. We'll
Okay.
look into the cluster management in detail with other tools inside it in the later times. So I hope, so you would like to have cluster in between, because cluster is the one that is going to be there in your office official environment look like. So you want that to be brought in as and when possible. Did I
Yes.
get it
And,
right?
regarding backup and restore,
Yeah.
will we be touching Ansible, because that will be the one of the tool also we will be using it here.
No, Ansible, no. So it's all very script based, command based. Ansible, there's no plan.
Because Ansible is one of the let's say requested tool that we want to go through this one. I think last introduction as well we discussed about Ansible that yeah it will be part of the tool section, let's say.
Can you check if
Uh,
what Vijay has shared with you regarding our
yes,
additional
yes.
topics?
Yeah, I'll just share that, whatever Vijay has shared it with me. With that titles only, I have segregated like this. So I'll just share my screen.
Well, yes, Ansible, yes, we will be looking forward for Ansible as well. I don't know if it will be included with part of repo buildup or parallel to this one.
As I see, there's no Ansible here. I'll just share my screen to you 1 second.
Yeah, because after with this one, when I was checking with Varshini, because this is one of the tools that we are looking, and she confirmed after checking internally that this is part of this one. And
So this is
so
the
maybe we can, yes.
yeah. So this is the list of topics that Vijaya shared to me, shared with me.
Okay. Yes. Okay, Alex, no problem. So this one, Ansible, we are looking forward for this one because I checked already during our discussion with Oceania.
Mhm.
So we
Okay.
need Ansible. You confirm it will be included. So if you can please add somewhere in any part two or part three, because I think
Okay.
we
I will check with Vijay, and then I'll get back. Yeah.
Yeah, anyhow, in for going, like we can add it somewhere if we all agreed. For now, we will
Mhm.
continue.
Yeah. So okay. So from your uh, comment point of view on this plan, so basically you would like to have the cluster management brought into part one. That would be good. And the second comment that you want to have is backup and restore. You want to have the Ansible brought in here. So for the second point, I'll check with Vijay and get back. And for the first one, so that can be done. So um, uh, yeah, so this is what it is. So we'll move ahead. Another thing is, okay, so normally when I give trainings to other batches, so you just give some exercises and things like that. How do you want to have it? So as a practice or practical things, how do you like to have it? So is that okay if I just go by the lecture that I gave along with some practical demos? Is that okay? How do you want to do it?
I think that should be okay in the during at least the part one. But we understand once we set up a node, as
Mm.
we I think discussed before as well, we will have an access to node. There we
Mm.
can go through the commands or run through the commands by ourselves.
Correct, correct. So that's what I was also thinking. You need to have at least, I mean, apart from your official production server, so you need to have a test virtual machine or a node. So for you to try or the commands
Yes.
or reproduce the things yourself in a test environment, and then you can try it in your before trying to your production environment.
It will be helpful, yes, in this way.
Yeah. So yeah. So then I will tell how to install a node and things like so. I'll cover that as well.
Okay.
Okay, so we'll move ahead with a introduction to Linux operating system. Basically, it's a free distributed operating system. So you guys know what's an operating system and all that. So I don't need to elaborate much. History behind that is basically it was developed by a student named Linus Torvalds in year 1991, based out of Unix. Comes under general public license, so whichever development that happens, so it has to be publicly published. Uh, published, which means it needs to be available for the public to use. And another thing is we need to know is Linux, as this is a bigger community, is keep developing this software. We would have updates coming every day. So at least we need to have a discipline to update the server as and when to keep the things up to date. Okay, so operating system, I'll give one word, is a software which will manage all the hardware resources, including the hard disks, input output devices, and memory. That's a software which would closely work with the hardware, and without that software, I mean, hardware would not be able to be accessed, or it will not be it will not give a platform for the users to interface. So operating system is a key software. On top of it, we have the application and we have the users. So this is what it is about the operating system. And coming to the Linux distributions, we have many popular distributions that we have. Uh, okay, I'll talk about the distribution a little later in another slide. So high-level Linux features are multitasking, Multi-user, it supports multi-user. Security is very good. It's network friendly, highly customizable. We can customize the operating system software footprint as we like. We can add and eliminate the packages and modules that we want and do not want. And it's compatible with a lot of hardware platforms. So a lot of good features comes for free. So people would like to go for Linux. So that's the secret behind the talk for Linux.
But just one question, Alex, regarding
Yeah.
this free,
Yeah.
terms of understanding. So between Ubuntu, CentOS, Red Hat, Fedora, and so on.
Yeah.
So there is no, let's say, implication of license in any so whatsoever. So there is no requirement of operating system as license in such case.
So Red Hat is an exception there. So Red Hat Enterprise Linux comes with some professional edition. So which means like they have built up a community and they support the software with a little more priority. And so except for Red Hat, all other things comes for free. So Red Hat, even Red Hat, yeah, there's a free version as well. There's a professional version as well. So there's a premium version and there's a free version. So two versions are available.
Okay, and whereas for the other versions, it's
Yeah,
fully
for all
free.
Ubuntu,
Yeah.
Ubuntu, CentOS, and other things all comes free. Yeah.
Okay.
Yes.
Okay. So only based on the, let's say, the latest releases and expiries, we have to follow this one.
Correct. So based on the, sorry, what's the question?
Let's say, for example, since it is a free version and the expiry of such versions and the release of a new versions are independent to any client. So we have a
Correct.
client has to follow as it is available on the market.
That's correct. So they don't actually, since it is a public community, we will not get a support based on a client basis. So there's no one who is going to maintain the operating system that we use in our enterprise because we ourselves should take the responsibility of fixing issues and this thing. So that's one thing that we need to understand here while we go for the free thing. Suppose, so for example, if there is a vulnerability bug, okay, so that's being announced. So, but if something comes as a very big thing, so it will get announced as a very big thing as well. So there are some communities for each of these things. There's a CentOS community, Ubuntu community is there, Red Hat community is there. So, and there are some blogs which keeps going on, and maybe we may have to be part of that to watch what's going on or what is being fixed and things like that. And in case if we add some things on a particular daemon or a process for our specific requirement, we may need to uh, um, think multiple thoughts before upgrading to the next version. We can do upgrade without upgrading the particular daemon or particular package. So there are options to do that. So all such things we may have to take care. Did I answer your question right, Shafi? So did I answer your question?
So
Yeah.
as long as
So
commercially, I just want to understand commercially if there is any impact in case if there is expiry or renewal. So as long as Red Hat premium version, which is the paid, all the other versions are free available and independent to the client, let's say, limitation. So in fact,
correct. So yeah, so that's right. So it's our responsibility to upgrade and keep our system updated. Uh, and we may also have to watch if there are some security fix which is coming up, which may need to be applied. So all of these things we may have to take care independently. So suppose that if there is a fix which is there which needs to be done on our server immediately, then probably we may need to do it immediately if we are maintaining it in a production environment. We can't wait for somebody to tell us, unlike it is a commercial based software. So if we buy a commercial based software, so the vendor would tell us that, hey, there's a bug in the software that we have delivered, so you need to fix it quickly, otherwise it will give this issues. So such kind of input we cannot expect when we go for a free. Yeah. So that's that we need to understand. Yeah. Okay, so we'll move on. High level Linux architecture, very high level. It just I've covered this just for a system administrator level. So at the center, we have the kernel, which is sitting on top of the hardware. Kernel is a core part of the operating system. On top of that, we have the system calls and we have the shell interface. Shell is an interface which we would use to interact with the kernel. The kernel would get the inputs coming from the shell interface and process it, gives back the reply back to the shell. And there are applications which will directly invoke the system calls and can talk to the kernel to get things done. And there are some library routines also application can use to talk to the kernel and get back for any specific requirements. So this is how the Linux architecture would look like at a very high level.
And where it starts to be different, let's say for between CentOS and Ubuntu, for example, of course the kernel layer is the same, but at what
Kernels
layer?
are same. Yeah.
At
So
what
kernel,
layer
correct.
different.
Yes. So so I'm coming to that. Okay, so now your question could be like, why so many distributions? So what is behind all of these distributions? Let's try to understand these terminologies. There's a hardware at the bottom. We have processor, we have memory, and we have devices. On top of that is the Linux kernel, and we need to understand the purpose of the Linux kernel is to control the system. Linux kernel is the one that controls the complete system. So that's the Linux kernel. On top of it, we have the desktop environment, which will actually give us the look and feel for the user's perspective. So it gives what to show and what should not be shown and things like that. What the system shows is called as a desktop environment. On top of it, we have the software packages. So these distributions basically have differences in the desktop environment and the software packages and not on the Linux kernel. So the Linux kernel would remain same in all of the distributions that we use, be it CentOS or Red Hat or Fedora or Ubuntu, whichever we use. Linux kernel remains the same. So we can build a Linux CentOS with the same Linux kernel. We can build a Red Hat or we can have a Red Hat with the same Linux kernel, but with a Red Hat Linux. So likewise, we can have different distributions with the same Linux kernel. The changes would be desktop environment and the software packages would, or the differences that we would encounter when we go for different distributions.
Okay. But are there any ownerships at this desktop environments? Of course, we understand this is where it start debating the CentOS, Ubuntu, Fedora. But is there any ownership? Let's say when we say Ubuntu environment, desktop Ubuntu environment. So there is any ownership behind this one?
Yeah. So ownership for the desktop environment. So as far as what I understand, my knowledge, basically, if you see there's a KDE. KDE Plasma is a desktop environment. This KDE is being supported in Ubuntu and KDE is also supported in Red Hat. But the differences comes in like KDE comes as default in Red Hat, but KDE you may have to install exclusively in the case of Ubuntu. So something like this. Some things are, but it's not like nothing is compatible. So it's not like, for example, you can take the DNF and the Yum and what is that? So APT. These are the packaging tools you might have heard of. APT is the one that's being used in Ubuntu, and M and what is it? DNF. So all of these things are being used in the Red Hat Red Hat tools. But if at all, if you want to work with APT in Red Hat, I think it's still possible. If you want to use Yum in the Ubuntu, yes, it's possible. But by default, they have their own packaging tool. To answer your question, if there is a owner for a specific desktop environment, as far as I know, so the answer is yes, because Genome and KD, there's a community. In case if you want to fix any, find any bugs, so they fix it. We can raise that bugs in that community, and we can expect the fix from that.
Okay, okay. And this communities needs kind of any registration, or it's like open, just sign up?
Open. It's all open.
Genome community.
Alex, regarding the kernel, you said it is same across all the systems, right?
All the distributions. Yeah, all the distributions. Yeah,
So
correct.
in that case, like, why do each one have separate software packages? Say, anyhow, it is going to use the process and memories related to same kernel, right?
To answer that question, so basically, what I understand is, for example, some flavors or some distribution has got some features little more. Those community people, for example, if you take Kali Linux, for example, there is a distribution called Kali Linux. So this distribution, they have developed more on the security side.
Okay.
So when compared to other distributions, so if you want to deploy something on very much on the security, people are preferring Kali Linux because it's all built in and it's available readily. And if there's a big what to say, there's a big research. I was just doing it. Which Linux should I need to go for the thing? So there's each, and if you want to use it for a home purpose, then probably they are talking about CentOS. And if you want to use for an enterprise environment, so people preferring Red Hat. And if there is a security, these things, people are preferring Kali. So they get their own distribute. They align with one distributions, and they go by that based on the requirements and the features that each of these distributions have in terms of these software packages. So not only the desktop environment is differing there. So desktop environment is not a big thing in the distributions per se, but the software packages is the difference maker here. So some software packages which are specific to security are built in already in the Kali Linux, and it's not so much done in the other versions. Something like that. You can imagine like that.
Okay.
Okay, so yeah, so that's how it is. So we'll yeah, so basically, are you still contemplating on the distribution that you would like to align for?
Means contemplate.
So do you still thinking whether you would like to whether you want to choose CentOS or Red Hat or something like that? So are you on the are you still on the analysis? Then probably I'm just thinking if you would like to.
I think our suggestion will be during part one. Let's say, for example, we will go through the different versions of Linux, so that we are familiar, about the different versions and so on.
I think you are asking in our project or
project
for the course?
in your project, because I as much as possible I would like to align my talks towards your project. Otherwise it will be irrelevant, right? So I want to be like that. So
Actually, our project our software was developed on Ubuntu, and soon, like they will be migrating. Sorry,
Migrating to
CentOS,
CentOS.
developed
Okay,
on CentOS,
fine.
and now
Okay.
they will be moving to Ubuntu.
Okay. So
So
Ubuntu and CentOS, there are no other
yeah.
changes there, right? Ubuntu and CentOS. So okay, so I'll go with that. So let's see. However, I have Red Hat and Fedora as well in my system. But anyway, so just asking. Okay, so we'll move on. Coming to different Linux distributions, there are distribution families. High level, you have Debian family, Red Hat family, and SUSE family. And these are the popular families. Other than that, we have so many other distribution families, but I'm not considering that. But Debian family, we have the Ubuntu and Linux Mint. And Red Hat family, we have the CentOS and Fedora. And SUSE, OpenSUSE, SLES, all of these things are there. And yeah, so these are the Linux distributions. Okay, so I'll talk about desktop virtualization now. Okay, so virtualization is a terminology which is being talked in many areas, including games and so many places. So now the virtualization technology is being brought in the desktop as well. So the desktop virtualization is something which helps us to install multiple operating system on one single hardware by creating a virtual hardware. So operating system needs a hardware, which is a computer hardware for it to get installed. So we need a computer hardware basically. But we have only one computing resource or computer hardware, and how to create multiple um, virtual hardware for the uh, multiple operating systems to get installed is what they thought about. And then they brought in a terminology or a new software technology called hypervisor, which helps us doing that. The hypervisor is a software that helps us create the virtual machine hardware out of the physical hardware that we have. We have a physical hardware that we have, and there's a hypervisor that we have to install on top of our physical hardware, which will be capable of creating the different virtual hardware. So we can create the virtual hardware as we like with the number of CPU and number of RAM, the size of the RAM and hard disk, and what things, how much memory we want, all that. So we can create our own virtual hardware. Once we create it, we can have the our preferred operating system to get installed on the virtual hardware. So these we can also imagine this the same concept being used in the cloud computing as well, where the service provider, they have a very big computer hardware, and then they give the services for all the public to use different computing resources created out of the big hardware they have, and they create the virtual hardware out of that. So that's how the hypervisor. In this picture, you see host OS platform. Host OS platform, we can have Windows or Apple or Linux or Oracle Linux, whichever we have. Only one OS we can have in the host OS, which will run on top of the x86 hardware or Apple hardware, whichever hardware that we have. And on top of it, we are going to install the hypervisor. In this case, I have picked up Oracle VM VirtualBox. So that's the name of the hypervisors developed by Oracle. And this hypervisor is capable of creating different virtual machine hardware. So we can create any number of virtual machine hardware based on the capacity that we have. So virtual machine hardware we can create. And once we create the virtual machine hardware, we can install the operating system that we like. So we can install CentOS or Ubuntu or Red Hat or whatever we want. We can install on top of it, and then we can run the applications on top of these virtual machines. Okay, so that's about the desktop virtualization. So I'm going to create, so this is the demo setup. Yeah. Is there any doubt?
No, we are good.
Yeah.
We are already using these tools.
Okay. So this is the setup that I'm going to use in my system. So I would like to show the picture. So I have a Windows operating system that's called the host Windows operating system. I'm explaining this picture. There's a host Windows operating system which has a Wi-Fi adapter which connects to my internet. I have an internet service provider which brings me the internet connectivity. There's a Wi-Fi internet adapter. Okay, so now I'm going to install the hypervisor and I'm going to create a virtual hardware. I'm going to install the CentOS on top of it. Okay, now the CentOS is going to be residing within my host operating system as a virtual machine, and CentOS would be running perfectly fine there. Okay, let's come to the connectivity part. So there's a when we install the CentOS on the virtual machine hardware, so there will be an Ethernet, there will be a adapter, network adapter that will get created, which is by default, which is a NAT adapter, network address translator adapter, which will uh, connect, which will make a connectivity with a Wi-Fi adapter that I have in my physical Wi-Fi adapter in my laptop, and fetches the internet connectivity, and hence the internet connectivity would be present within my virtual machine. So internet connectivity get established when I install the CentOS. So internet connectivity is very much required for the virtual machine for updating the packages. We need to update the package, and we need to have our Linux operating system up to date. So we need to have the internet connectivity. So this internet connectivity would be established when we install the CentOS. And CentOS can, this virtual machine has the ability to create multiple network adapters. We can create multiple network adapters, additional network adapters, which we would be creating as we move along to the part 2 and things like that. Okay, so this is a stepwise installation I have given. So do you want me to explain? Do you want me to go through? So I'll just quickly go through. So VirtualBox, we have this software freely available in virtualbox.org, wiki downloads. You can download it, bring it up. And there's an extension pack, which is also present in the same location, which we may have to download and install the VirtualBox extension pack. And once you install the extension pack, the extension pack needs to be installed using the tools, the extension, and install. It will open up a browsing window, and you can select the extension pack utility and get it installed. So once 1, 2, 3, 4 steps will have the VirtualBox installed perfectly in our host operating system. And the 5th step is what we have to create a virtual machine hardware with a required size. I have just put 6 GB and 2 CPU and 50 GB. So this is what I like to have. It's again based on the amount of memory that you have in your system. You can reduce it, but do not reduce it less than 4 GB for RAM. 2 CPU is good, but 50 GB can be less reduced to minimum 20 or 30 GB. So 25 GB, 20 GB should be fine. Yeah. So the more memory is good for us to try different things. So keep that in mind. But lesser, minimum should be 4 GB. So if you go lesser than that, you will find it a little difficult running your host operating system and your virtual machine operating system. So download the CentOS IOC image, which is present in the CentOS org. Can download it, then feed it inside the virtual machine hardware, inside the optical drive, and you can feed this IOC image and then start it. It will take some time to install, and it will take you through different wizards. So it will, as you move along, you can finally it'll install the CentOS onto your virtual machine hardware. Before rebooting, it'll prompt you to reboot the machine. So before rebooting, you just have to remove the ISO image from the optical drive. Otherwise, it'll keep installing again and again. So we may have to remove the ISO image from the optical drive. So these are the steps which we may have to follow to bring up a CentOS node or a virtual machine in your host operating system. That's your laptop or whichever thing that you have. So I feel like you may need to have such a environment at your end to try different commands um, when we uh, learn. Is that okay? Is that a fair expectation?
Yeah.
Yeah. Okay, so shall I move on? So is there any questions, any doubts? I'll just finish off in 5 minutes. 5 or 10 minutes, yeah. Is there any questions so far? Like, is there everything okay? Just you may have to give me feedback, otherwise I'll keep on talking. So you may have to stop me in case if you have any queries.
Alex,
Yeah.
our understanding was like we will be working together in a virtual environment, right? So it is not like that. Now we have to have our own setup.
No
Because
problem. So you can, and we will be
as part of
working to
training,
working together in the sense like I'm fine if you I have my system. So if you want to see that and uh, when you work by yourself, you will get to know. Otherwise, if I demonstrate to you, it will be a theoretical thing. So that's my way of learning. So you can decide. I can keep demonstrating
even we
and
prefer to work on by ourselves. We thought like we will be sharing same virtual box or something. To like you will be making one system and we will be making other systems, and at the end we will make a cluster. So our understanding was like that. So if it is the case, like we have to prepare workstations for this. Our laptops, I don't think we can make this split for virtual box.
sorry, Senthil, I didn't quite get that. So, are you saying that I'll be creating a virtual machine from my end, and you will be creating a virtual machine from your end, and we
No,
will
I
make a
thought
setup?
like there will be some Azure platform like where we will be giving, you will be giving us access to build. I was thinking in that way.
No. I mean, we don't have a license. No, at least I don't have a license for Azure,
Okay.
and
Anyhow, so this is also workable. So just we will set up machines.
yeah. So, are you? Is your environment is going to be on Azure?
No,
Okay, so then I don't think you need Azure because Azure would be a
we will
different
have to
working.
check with our corporate IT whether they have any licenses for Azure, so we can share this one.
No, what I mean is getting a computing resource in Azure and running DHCP is very different than. I mean, basically, one more thing, and while we are discussing this, are you trying to build a cluster on an on-premises equipment or a cloud environment? So that's a
On
basic question.
premises, on premises.
On-premises, then
Physical
I
machine.
don't. So then you don't need to go for cloud, is my opinion, because cloud will bring in a lot of other parameters that you need to know. Otherwise, you can't do DHCP. So many other things would, because it's a public environment, and a lot of things would needs to be taken care, and all of these resources comes with a high cost. So yeah, so I don't think that's a good way to
It's
show.
correct, Alex, but during this training, we want to get the concept of that options as well.
Yeah, broader scope.
Obviously, yes, obviously, we say we will focus mainly on this type of OS versions and this kind of setup and so on. But the generic understanding of the Linux, the different setups,
Yeah.
maybe we'll have the hybrid environment as well. So we want to understand that concepts as well and how it works. But of course, not we will not go as a practical steps. But yes, we will understand at a admin level and what we need to know as a main part.
Sorry, Shafi. Sorry, I got a little bit lost. So, are you saying like you would like to have this environment set up on a cloud for demo?
Yes, we want to experience this as well during the training.
Okay,
I mean,
so
we have one with you, right, already, so we will experience the same.
okay, so I have not planned it with a cloud. So, but cloud is a different training as altogether. That was not shared with me. So cloud is another set of things that we need to know before we work. I mean, but all these things are all primitive, I mean, preliminary things that would really help when you go on to cloud. If you take up another course on a cloud, all of these things would definitely help as you move along. I think what you are planning is you will start with a on-premises equipment and then you would like to go for a hybrid later. And so you would like to have the training for the cloud as well. But I think the cloud training is a different one. So I think you can discuss with Vijay about that.
But we
So
will
cloud
be
is,
for the concepts for that approach, no?
yeah, cloud concepts are a little different because, for example, if it is user management and it is a file permission, it's a file permission here. So there is an identity access management, which is completely different. So it's very different in when you come to cloud, and there are regions and so many resource groups. So many things are there which are just to create a compute resource in Azure or AWS. I mean, we need to set up a lot of things, and we need to understand so many things before that to set up to bring up a Linux as such.
Okay, but do you have something available or something you are using already with you?
Uh, so basically, so that's what I was saying. So I don't have Azure is basically a little bit costly. AWS I had, that was also it's all comes with cost. So I had closed it. At the moment I don't have an active license. So in case if you really want to have, I mean, have a look, but I can spend 5-10 minutes time to show you some things. But again, if you like to learn about cloud, it's an exhaustive thing, and that you can't do it together. So
Okay, I mean, our intention is mainly to at least get to know the
yeah.
concept. Yes, building it or working on it practically, no, we agree with you. But at least the
Mhm.
concept wise, if you have few slides for that concept, so maybe you can go through, like for those to explain the different concepts.
Okay, so that also then you would like to add it in the training topics.
Oh, I
Then
think
I
you
will.
mentioned somewhere part two, no, about this one. If I
No, no, no,
have
no, 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 no. So
okay.
all of these networking topics that I have mentioned are all on the on-premises stuff. So it's nothing to do with the cloud.
Okay. Some conceptual slide, if you have it, I think it will be helpful at least to know because this is
Uh,
related to this one.
so concept,
Conceptual.
Shafi, so the point here is, if I have to touch upon a cloud here in any of these things, first thing is I need to bring up a computing resource, EC2 in case of AWS. So to bring up EC2, we need a lot of things. So we need to know what's a root user. We need to know IAM user. And here, there's no such concepts here. So IAM user, if I have to explain IAM user, so many things, the roles and other things are very different in AWS. Such things are not here in Linux. If I try to bring in the cloud concept, that will be a different topic altogether. So we need to take a call if you really want to add those topics in this training. So otherwise, we should not have a misunderstanding in the expectations once we
Agree with
complete
you.
this
Agree.
training. Yeah.
Agree. Clear. So as long as if you have a couple of slides handy with you, then you can share, explain to us this is how the cloud concept works. Not
Mhm.
go in a detail. Then we will focus on the on-premises concept. No problem for us.
Yeah, so as of now, we'll focus on on-premises equipment. So if you really want to know more, I probably you would like you may need to talk to ACT. There's a specific separate training requirement. Training is there, cloud training, so you can take that. And as and when, if I could touch upon something on cloud, maybe I can talk about that. But if I have to bring in a AWS slide in here, which will not fit in here. So it's a altogether different ballgame. You cannot give a correlation. For example, how DHCP works in on-premises and how DHCP works in cloud is going to be very different. So I need to create a private network. Such a private network concept is very different in on-premises. Private network concept in cloud is very different because we are running this resources in the public area. So the things are a little different there. And if we have to touch upon that, we need to bring a whole set of other things to know. So each and every concepts are advanced. So if you talk about bash commands, there is a set of other commands that we may use in AWS. So if you talk about file system, there's an elastic file system, which we don't use in on-premises equipment. So user management, same way, there's an IAM there in AWS. We don't have it in here in on-premises, which is totally irrelevant. And if I try to explain that concept here, which is also irrelevant. So yeah, so it will be like that. Yeah. Okay, so we'll move on. Okay, so just check if we can set up a setup. Otherwise, I'll go on with the setup that I have, and you can take a look and you can work on that. Or else, if you want to set it up for you, I can do that. So that's also I can do in your system. If you
the
want.
process with us available now. So mainly it's like a laptop that will see the training. So if I don't know if you have resources like a VM already available with you, we can set up.
No, if we, I mean, okay, so so the VM, I don't have a VM as such because we don't have an infrastructure here. A hardware infrastructure, it was not a requirement. That's where is the issue. So it's not a very big thing. So if it is allowed in your office, then you can create these virtual machines. If it is not possible, then probably you can leave that as well. So we can watch from my system and take care of that.
Okay.
Yeah, or if it is possible for you to bring in your own personal laptop into your office, I'm not sure if that's allowed. So then that's also a possibility. May have to check that.
Okay.
Yeah. So yeah, so that angle is what I was actually thinking. I was discussing on the lab part on the first day itself. So I was wondering whether you got it right. So that day. So I was actually talking about this. So generally what we do is we have the candidates to have this VM setup on their own laptops. Because we cannot have those VM setup over here and give you access. That's not possible. So so that's how it is.
Okay.
Yeah. Okay. So we'll move on. Linux boot process is basically a 6-stage process. Basically, it starts with the input-output check, which is a BIOS software, which is done by the software called BIOS. As you'll do the input-output check verification. All the input devices and output devices verifications are done by the BIOS. Just after that, it'll go and execute the another location, or it'll read the MBR. MBR is nothing but master boot record. The master boot record is a 512 bytes of information which is stored in the first sector of the memory. And it'll have the bootloader and the partition table. Bootloader, which holds 446 bytes. And the partition table will have the next 64 bytes. So bootloader is again a software which will load the operating system into the RAM. So running the operating system from the hard disk is very time consuming. So bootloader helps us copying it to the RAM so system can run the software from the RAM. And partition table information will have all the information about the partitions. So what's the start address, end address, and so on. And so these are the information that will be there in the master boot record. So just after the master boot record, it will go and start executing the information which is there in the bootloader from the start. So there's a bootloader software which I showed, which I told. So it will start executing the instruction from the bootloader software one by one, and it will copy it to the kernel. I mean, it will copy the kernel to the RAM and start executing. The bootloader that's being used here is called grub, GRUB, Grand Unified Bootloader. So that's the one that's being used here. And once the bootloader is finished its job, the kernel needs to be get executed. Kernel execution starts from the place where the bootloader informs. So kernel would get executed from the location, and its first process that the kernel would bring up is the init process, which is present in the S bin. S bin init is where is the parent process, which will spawn the first process, and this init process spawns the first parent process in different run levels. So it's capable of bringing up the parent process in different run levels. It has got around 7 run levels, 0 being the halt, 1 being the single user, 2 the multi-user, 3 the full multi-user, 4 unused, 5 is the full-fledged GUI, and 6 is the init group init reboot. If you give init 6, it will start rebooting the system. So this init is a software which will bring up the kernel in different run levels. And a run level means basically it's a run level is having a set of scripts for each of these run level, and these scripts will say which of these applications needs to be spawned and which of these applications needs to be killed based on the run level. So there are different applications there which would get run and which would get stopped as we choose the different run levels. So the master boot record that I talked about is how it look like. The first sector has the master boot record. The blown up diagram is shown here at the bottom. The 440 bytes is the bootloader software that I talked about, and has a 64 bytes of partition table, which is also a key information stored in this MBR. Just after this, we have all the different disk partitions in the memory. So this is how the master boot record would look like. I talked about the init process. So init process, we have 7 levels. The init process looks up the level which needs to bring up the Linux, and based on this level, it will bring up the Linux. And these run levels are stored in scripts, as I mentioned. For each of these run levels, there are different scripts which are present in rc.t under etc directory, etc and rc.t. So we have different run levels. Under that, we have different files which will tell which of these programs need to be started and which of these programs need to be stopped. And we can change the run levels in a system by giving the command tell init. Even when the system is running, we can change the run level by giving the command tell init and different level, which will switch the level from one level to other like this.